Hey everyone, Mr. Skelton here. We are back at it. We are going to start lesson 9 in Unit 2, and today we are going to try to do two things. The first one being that you can multiply a matrix by a scalar, and I'll explain to you what a scalar is. And second, that you can multiply a matrix by another matrix. So let's jump right into it. This first problem here is multiplying a matrix by a scalar. This number out in front is what we would consider to be a scalar. So we're going to take that 2, and that 2 is going to get multiplied by every element within the matrix. Just for review purposes, this is a 1, 2, 2 by 1, 2, 3 columns. That's a 2 by 3. And when you multiply by a scalar, you should still get a 2 by 3 over here, just with every term multiplied by 2. So you should get 24. 2 times 4 is 8. 2 times 4 is 8. 2 times 7 is 14. 2 times negative 8 is negative 16. 2 times 5 is 10. That's basic scalar multiplication of a matrix. Moving forward. So here we're going to solve a matrix equation. It looks a little bit more involved, but really what you're going to do is just follow, off the paper there, that would help. There's number 2. We're going to follow our, I'm going to write this down, PEMDAS, but basically order of operations, right? You want to follow order of operations here. So the first thing we want to do is think of this problem as like negative 3a plus 2 times 4 equaling, I don't know, let's see, 18, okay? So that's how I kind of want you to think about this matrix problem. Well, what would you do? Well, you would see this 2 times 4, and you would multiply the 2 times 4 and get 8. Just like you see here, this 2 times this matrix, we're going to take that scalar of 2 and multiply it through. So we get negative 3a plus 8 equals 18. Then what would we do here? We would subtract 8 from the 18, okay? And get 10, and we'd end up dividing everything by negative 3. If you follow this path of just basic solving equations and apply it to this, it's essentially the same thing. So what we're going to do first is take and multiply our scalar of a 2 by everything in this matrix. So that would give you 12, negative 24, that would give you 18, this would give you 30, and this 27, 30, negative 18, and 6 stays as is. You only apply the scalar to the matrix that it's by or on. Next, we are going to subtract this 2 by 2 to the other side, okay? So this becomes a 12, this is still my negative 24, 18, and 30. Now you have to be careful of your signs, so let's walk through this. I'm going to take each term, so you've done this before, this is subtracting a matrix. You're going to take each term, this is a 2 by 2 and a 2 by 2, so we can do this. And we're going to go 27 minus 12, okay? 27 minus 12 should give us 15. You have a negative 18 minus 18. That should be a negative 36. So you have to be careful with your signs here. Just go slow. 30 minus a minus 24. Double negatives would turn into a positive, so that would become a positive 54. And then you have 6 minus 30, which would be a negative 24. So that's what happens after I subtract my matrix to the other side. Now, technically, there's no division when you do matrices. We always multiply, but you can think of it as division. Technically, we should multiply both sides by the reciprocal, which would be a negative 1/3. So that would negative 1/3 times positive 3 would cancel out to make 1, and we would just get a, which is what we're trying to solve for anyways, right? We're trying to solve for a. But I always think of it as division. I always think of, okay, I'm going to divide each element here by negative 3. So you can go ahead and do that. So 15 divided by negative 3 would be negative 5. Negative 36 divided by 3 would give you a positive 12. 54 divided by 3 would give you a negative 18. And negative 24 divided by negative 3 would give you a positive 6. And so that would be our answer, okay? Moving on, now we're going to change gears a little bit here. This is our second learning target, okay? This is multiplying a matrix by another matrix. And this has a couple of different rules, but I'm going to kind of show you this example and then kind of show you how this works. So here's the situation. Let's make it an application problem and it should be able to make sense to you. So we have teachers here. We have teacher A, teacher B, teacher C. This column is markers, this is erasers, and this is staples. And we're multiplying this matrix by, this is cost. I don't have any dollar signs in there, but $1.25, $1.20, and $2.25. And what these prices represent is $1.25 for markers, $1.20 for the erasers, $2.50 for the staples. So essentially what this situation is these three teachers are going shopping before school starts, right? And teacher A is buying 55 markers, and markers cost $1.25. They're buying 2 erasers. Erasers are $1.20, and 2 staples, boxes of staples, where they're $2.50 a piece. So what we want to figure out is the cost that each teacher had to pay in order to get the supplies that are listed here for the price given. So let's think about that for a second. Let's focus on teacher A. You may need your calculator, and that's fine. Teacher A bought 55 markers for a total of, or for $1.25 a piece. So we want to take 55, we want to times that by 1.25. So basically teacher A spent $68.75 on markers. Teacher A also spent bought 2 erasers for $1.20. 2 times $1.20. That's going to give me $2.40. And teacher A also bought 2 boxes of staples for $2.50. So 2 times $2.50 would be $5 there. So let's add all those up. So $2.40 plus $5 plus 68.75, and that gives me a total of $76.15. Now, I want you to think about how we got that for teacher A. We took each element, we multiplied it down the column that it was multiplied by. You're going to see that theme or that concept carry over. Let's do teacher B. So teacher B is this row right here. So this row of teacher B is going to get multiplied by this column of the markers, erasers, and staples. So teacher B bought 10 for $1.25. So that should be $12.50. 3 erasers at $1.20, so 3 times 120, and that gives me $3.60. And 3 staples for $2.50, so 3 times $2.50, and that gives me $7.50. So let's add all these up, okay? And we get $7.50 plus $3.60 equals plus my $12.50, that equals $23.60. So that's for teacher B, all right? So teacher A spent $76.15. Teacher B spent $23.60 on all their supplies. Now, I want you to hit pause and try teacher C. I want you to find the total cost that teacher C spent when they bought 15 markers, 1 eraser, 4 staples. Okay, so teacher C is this row right here, the 15, 1, and 4, and these are the prices that are associated with the markers, erasers, and staples. So 15 markers at $1.25, so 15 times 125, it's going to be $18.75, okay? And then I'm going to add that to 1 box of erasers for $1.20, so that's just $1.20, and then 4 staples at $2.50, 4 times $2.50, it's going to give me 10. So I'm going to add all of those up, so 10 plus $1.20 plus $18.75, and that gives me $29.95. Okay. This concept, this is how we are going, or how you are going to multiply matrices. Now, I'm going to point out something that's real important for you, because if you multiply these together, here's how you would list these answers appropriately in a matrix. It'd be 76.15 for teacher A, it'd be 23.60 for teacher B, and 29.95 for teacher C. If you take this matrix times this matrix, you get this matrix. I'm going to show you how this works. You already kind of did it, right? Teacher A, teacher B, teacher C, teacher A, B, and C. This matrix right here is a 3 by 3. What is this matrix right here? This is a 3 by 1. Now, here's the rule of thumb when multiplying matrices, if you're going to multiply these matrices, what you want to look for is this. The only way that you can multiply matrices, this is a little memorization trick, is if these two numbers are the same, which they are. When these two numbers are the same, you can multiply the two matrices. Step one. Step two, how do you know what your final matrix is going to look like? That is these numbers right here and right here. I know you can't see that, so I'll write it in here. 3 by 1. If these two numbers are the same, then the matrix that you're going to get as an answer will be the first number and the last number of 3 by 1. So this is a 3 by 1, and you can see that right there. Okay? So let's apply that concept to another problem. I'm actually going to have you try this one on your own, but it's essentially the same kind of concept. So here's the situation. We have game 1, game 2, game 3. These are seats. So you have the lower level, the middle level, and then the nosebleed seats. And this is the cost for lower level seats, middle, and high. So this must be something important like the Super Bowl or a playoff game or something like that, because ticket prices are pretty high. But basically what I want you to be able to tell me is, for game 1, what was the total cost for the lower, middle, and high seats? For game 2, what was the total cost? So I'll get you started here. I always test. Okay, it's multiplication, so this is a 3 by 3, and I'm going to times this, and this is a 3 by 1. So I always just check. Are these two the same? They are. So what's my final answer going to be? My final answer is going to be a 3 by 1 matrix. Okay? So the rule of thumb is we multiply row by column, row by column, row by column. And every time you multiply them as you go, you add those terms together. So, for example, I'll get you started and I'll let you finish it. I'll do game 1. So for game 1, it was $50 times 450. So that's, did I put that in there? Yep. So that's going to be 22500. Okay. And then I'm going to add that to 30 times 200. That gives me, let's see, 6,000. This was what, 22,000? Okay. And then I have my last term in my first row times my last term in my last column, so 20 times 100. That's going to give me 2,000. Okay. You add those all up. And that gives me 23300. So 1, 2, 3, 1, 2, 3. So, oh, I have a wrong number in there, I think. That can't be right. It's 22,500 plus 6,000 plus 2,000. That's a little off. That sounds better. That's going to give me 30500. So that would go right here. So what does that mean? That means for game 1, the total cost paid in tickets was $30,500. Okay. Now, for the sake of time and to keep this video short, if you want to, you can go ahead and find 2 and 3 what their cost was. But I'm going to jump down to a problem that you're more likely going to see on a quiz, test, or homework. So you can see here that we're multiplying these two matrices together. But what I was just doing in the question above and the one previous to it is going to hold true. I always look, first of all, it's multiplication. This is a 2 by 2 matrix right here, 2 rows by 2 columns. This is a 2 row by 3 column. So I always check, are these two numbers the same here? They are. So the result is going to be a 2 by 3. So this is going to be, my resulting matrix is going to be 2 rows by 3 columns. And that's going to be my final answer, a 2 by 3. Okay? So how does this work? Well, we know it's a 2 by 3, so I'm going to have 3 terms and 3 terms. I take my, you always multiply row by column. Okay? That is how we do it. So I'm going to take my first row and I'm going to multiply it by my first column, and that's going to give me my first term in the upper left-hand corner. So it works like this. Negative 2 times 4 is negative 8. I'm going to add to that 5 times 2, which is 10. What does that equal? That equals 2. So 2 goes there. Now I know I just used some pen, which may have been a bad idea, But I'm going to take this first row, and now I'm going to multiply it by this second column. I'll underline. So negative 2 times negative 4 is going to give me positive 8, and I'm going to add to that 5 times 6, which is 30. So negative 2 times 4 was negative 8, 5 times 6 is 30, add those together, and I get 38. And that goes right here, because it's the first row. So I'm just going to first row. First row, last column, I'll put a box around these, or I'll just put a little dot. Okay? Negative 2 times 1 is negative 2. 5 times 3 is 15. Add those two together, and I get 13 right there. Okay? Now, that's my first row, and I went through all 3 columns, so now I need to go second row, and that's going to give me these numbers down here. So let's do that. I'll go in black pen here, see if this black pen works. It does. All right, perfect. So I'm going to go second row, first column, and that answer is going to go right here. So 3 times 4 is 12, and I'm going to add that to negative 1 times 2, which is negative 2, and that should give me 10. For this number, right here, this element in the matrix, that's going to be my second row, second column. So 3 times negative 4 is negative 12. I'm going to add to that negative 1 and 6, which is negative 6. That should give me a negative 18. And then for my last element, I'm going to go my second row and my third column. 3 times 1 is 3. Negative 1 times 3 is negative 3. Add those together, and I get 0. And this is my answer. Okay? See what I got anything on the back page. I do. All right. So I want you to try this one on your own. So go ahead and hit pause. See if you can do it, and then I'll go through this one with you. Okay. So I always double check. I got a 2 by 2 here, and I'm going to multiply that. Now what is this? This is a 1, 2, 3 rows. Remember, it's always rows by column. By how many columns? 1, 2. So this is a 2 by 2 times a 3 by 2. Just double check. 2 by 2. This is a 3 by 2. Now, do these numbers multiply? Are those numbers the same? They are not. So you can't do this problem. So I wanted to show you one because I don't want you to just think all the time that if you have two matrices multiplied by each other, that you're going to be able to multiply them out. You have to double check when you name or write what this matrix is based on its elements. 2 by 2. This is a 3 rows by 2 columns. These numbers have to match. If they don't match, you can't multiply it together. Okay? And you would know that. I probably shouldn't have crossed it out, but just take a look. If I go first row, which is right here, I'll highlight them. By my first column, watch what happens. Negative 2 times 6, 5 times 3, but then you have this number all by itself with nothing more to multiply it by. So that tells you right then and there that it's just impossible to do, right? If you went, first row, second column, negative 2 times 2 is negative 4, 5 times 4 is 20, but then you have nothing to multiply by this 7. So you can't do it. So that's why I always start with this right here and double check to make sure I can multiply the two matrices together. Okay? I hope that was helpful. Some of this can be a little confusing at times. You have to work slow and just make sure you're always going row by column and adding those elements along the way to get your total. I'm sure I'll have some questions in class, and I'll be happy to answer those for you.